This image describes the basic setup of the experiment that you're about to perform. A weight of 500 grams is hanging from a string that is held from a fixed point, and that is further attached to a force sensor. Note that the force sensor is not included in this picture, but it is shown at the very top right of this slide. The sensor measures the force exerted on the string. The two red arrows indicate the force is at play, if of course one considers no air friction. Study your lab manual for a more detailed description of these forces. Now on the left-hand side, we have the so-called position sensor that acts as a sonar. In other words, it sends and receives acoustic waves, and based on the Doppler phenomenon, you can estimate the distance between the object of interest, in this case the weight, and the sensor.
Now it is time to collect some data. Remember, we have two sensors, the force sensor measuring the string's tension, and the motion sensor that detects the position of the pendulum. We consider that the distance is estimated along a straight line. The data we acquire are sinusoidal functions of time. You can see a sample of the data at the bottom of the screen. The three panels indicate force versus time, position versus time, and finally velocity versus time. Now keep in mind that the position sensor does not actually calculate velocity, but this is derived as dx over dt. From the data preview shown here, and by studying the lab manual, try to figure out how one variable, for example the tension, changes with respect to the other, for instance velocity or position. You can find the link to the actual data in your lab manual, and you will use this data set to answer the questions 1 through 3 in your report.